All right, so now we can talk about the next part of this chapter, this beautiful chapter 8. And let's fast forward to that. I think it was, there we go, stored procedures. Okay, so stored procedures are great. So as a program, I manage a team of developers, and they develop different applications and websites and web applications. And we have a rule in our company that our programs are not allowed to reach out to the database and do queries straight to the database. You cannot do in your code, select this column from what have you, even just a read and pull back. We don't allow that because we want in our architecture, we have a stored procedure architecture. So everything that the application wants to do has to go through a stored procedure. Some stored procedures are as simple as, like I said, a basic query like, hey, get this guy's name from the database. Even oftentimes our login is a pretty simple query to the database, and we don't do it straight through the code. We do it through stored procedure. So while that's great, applications can use stored procedures. Databases can use stored procedures. In fact, sometimes we have applications that call into stored procedures that then call into other stored procedures. Data is returned back to the main stored procedure. It's massaged and handled and then handed back from that stored procedure right to the application. So it's great. It is a way to wrap bundles of code together for a common purpose. It's useful, as we just talked about, in client-server systems. Some of the advantages of procedures is stored on the server, that the database management system compiles stored procedures, creates compiled and optimized code to run. This is a big piece to this also. Stored procedures, while they're scripts, the database management system actually does compile it down into machine code and runs it. And it oftentimes is faster. The database management system also has the ability to optimize the code to make it run a little bit better. If you get a strong DBA in your team, they can even help the DBMS optimize better. All kinds of really cool things. And it's convenient. You don't have to keep writing these scripts or loading these scripts or saving these scripts. You're going to create something that's somewhat accessible. Now, for those using Access, I'm sorry, stored procedures aren't really made use of, and we will talk a little bit about Visual Basic and how to use it for Access. I don't want to cover it too much. I know you're going to have some test questions on it. I apologize for that. It's great to know the information. We're going to buzz through it pretty quickly. Make sure you do study up on it a little bit for the test. So retrieving a single row in a column, we're going to use the create procedure command to create our stored procedure. We're going to use the type attribute to ensure that the variable has the same data type as a particular column. And what this means is when we are asking for input, we need to tell our database management system what type is going to be expected. In Oracle, we can actually tell it, hey, use the type of this particular column. So if that column that we specified is of type integer, it will be that same type. So we'll see that here in a moment. Procedural code is located between the begin and the end commands. Each variable declaration and command, as well as the word end, are followed by semicolons. Again, our database management systems can be a little loosey-goosey when it comes to semicolons. I'm telling you, though, when it's really expecting one and you forget to put it in there, it's going to take you forever to find it and to fix it. Get into the habit, get used to using semicolons. I cannot tell you how many development hours have been lost to missing semicolon. The slash at the end of a program appears on its own line. This is very much an Oracle thing, but I just wanted to kind of let you know about that, and we're going to see that here in a moment. So here is our first stored procedure. We're going to create or replace procedure, and this is the procedure name that we're giving it. This is the customized name that we would like to give it. And by the way, you can't have stored procedures with the same name. So make sure you pick a name. And then the argument. Now, remember what I told you back on this slide. Type attribute ensures that the variable has the same data type as a particular column. And the reason why I wanted to show that to you is we are now going to tell our store procedure what inputs we're expecting. Remember that. This is the inputs. So I rep name in, and this in rep.rep num as percent type is saying, hey, make this input, this I rep number input, the same type as this table column. So if it looks at the rep table and the rep number, by saying percent type, we're saying, hey, it needs this I rep number is going to be the same type. The reason why this is convenient is oftentimes the input is just that. It's going to be looking at this column for some kind of piece of data. So if that's the case, then we want to make sure that this rep number matches that type. Don't forget the word as. You're going to forget it, just so you know. You're going to forget the word as. You're going to get some errors. It's going to drive you crazy. I'm telling you now, make sure you check to make sure the word as is there. Now we're going to create some local variables in this script, in this piece. Let me see if I can, let's blow it up just maybe 150%. All right, so these are variable names that we are creating within the stored procedure. In fact, right now, we're not going to even put any information in those variables. We're just holding on to them. This one in the parentheses is an input variable. These are variables that we are creating that we're going to make use of in a moment. Then we got to start our code. Begin. Please remember local variables. Put them before the begin. Begin and end. End of the store procedure. Select last name, first name. Now notice that the last name and first name are actual column names from the table rep. Into, this is a new word for us, into I last name, I first name. So what we're going to do is we're going to say select the last name and first name and shove that data into these variables that we just made. In fact, that's why in this case, we're saying the column last name's type, and for the first name, the first name type, because it makes sense. Since we're pulling that data and shoving it into these variables, make sure they're the same type. From the rep table, where rep num equals, and this is our input variable that we asked for, I rep number. And then we're going to say dbms underscore output dot put line. We're going to talk about this here in a second, but just here's a little teaser on this. This DMS output package is a package that has several different embedded functions that we can make use of. One of them is put line, and it simply basically prints line out so we can take this information and now print this line out. So we're going to write trim. We talked about write trim already. That first name, we're going to put the two pipes in there so that way we concatenate. We're putting a hardcode space, concatenating again, right trim, the last name. Now look, we're not using the last name and first name as the column because we put that data into these variables. In fact, if we didn't do the into I last and I first, as soon as this query ran, the last name, first name, gone, because we didn't put it into a variable. So we always want to make sure we're putting our data that we're pulling back into a variable so we can make use of it. That's what we've done here. Don't forget our handy dandy little end with the semicolon. And in Oracle, we do a slash. Once we hit run on this, it will create a stored procedure for us. And and by the way, the reason why we did the create or replace is because later we're going to make some changes, let's say, to this procedure. By having the word create or replace, Oracle's smart enough to go, okay, it already exists. They don't want to create another one, which you can't anyways. We're going to replace what's already there with this. So we already talked about this. When executed, the user will be prompted for a value for I rep number, which is our input back here. That value will be used to retrieve the last name and first name of the sales rep whose number equals this value. And we talked about that. It's part of our where clause down here. The results will be placed in the variables. First, we created the variables, and now we're shoving data into them. This DBMS output dot put line, it's what we just talked about. It's part of that DBMS output package, and it will allow us to display the concatenated and trimmed rep's name. Just to finalize, that DBMS output is a package that contains multiple procedures. You should do a Google on that. See what the procedures are in that output. We typed the begin, we did the procedure, we did the arguments, and semicolon slash. Kind of a recap of what we did. Now, how do we use that store procedure? We've created the store procedure, but let's use that store procedure. To use the store procedure in Oracle, we type the word begin. We type the name of the function, the store procedure we just created. We go ahead and pass in parentheses, and in this case, semicolon and single quotes because it's not expecting numbers, it's expecting data. And actually, I believe that is a number field, but again, we still put it in single quotes. With the semicolon, don't forget the semicolon. Then we do end and slash again. Once we run this, it's going to run that stored procedure, and it's going to return Megan Grady, all in that one line. That is, by the way, exactly what that DBMS output put line is doing. It's the one printing out to our results table. You also know it's not really a table. It's kind of like a text entry. Pretty easy. So let's talk a little bit about error handling. So here is our store procedure. I believe this is the same one. We're going to blow it up again. Yep. And this time, we're going to make an exception. So what if something bad happens here? Well, what if we put a number in, when we type this in, we give a number like 99,000, something that doesn't exist, right? When it tries to do this query, it's not going to find any results. And so we want to make sure if no results are found, it still does something. So in this case, we're using the word exception. That tells the DBMS, hey, if something goes awry, look in this block of code to see if we should do anything. And in this case, we're saying when, no data found, then. So we can type in different reasons that something might go wrong. We might say, hey, if the code crashes or if something like this happens, do this, right? In this case, we're saying, hey, when no data is found, and exactly you want no underscore data underscore found, then we're going to do this. So when no data is found, we're going to say, hey, no rep with this number. And we're going to concatenate the rep number that was given to us, just to make it nice and neat. Now, I don't know if it actually shows that as an example, which of course would have been really nice for it to do that. I do recommend, this is a fun little test. Take this in and try it, and try that 9,000 or whatever number doesn't exist. All you're going to get is this line says no rep of this number, and then the rep number. Notice how there's a little space right there, and then we do a semicolon to close off, and then we do our double pipes, and then we put the rep number. This makes it to where you'll say no rep number with this number, colon, space, and then the rep number. All right. Using update procedures. So again, the store procedure we just used, all it did was read data. You can also use store procedures to update data. So in this case, we're saying, hey, create or replace the procedure, change customer name. So the first thing we need to do is tell me the customer number. This is the input, customer number. It's the type of customer.customer number. So here's that percent type. So whatever this number is that the user is about to type in, it better be of this type. And then you'll see a comma. Well, the comma says we're going to add another input. We can have multiple inputs in our store procedures. In this case, iCustomerName in customer.customername %type. So again, we're expecting input that we're going to put into the iCustomerName variable. It's going to be incoming to us, and it's got to be the type of the customer name. Now, not a spoiler alert, this iCustomerName is what the new name's going to be set to. So I got to be honest with you. In my world, I would have made this a little bit more descriptive variable name. I might have said I_new customer name or updated customer name, right? So that way, it's not confusing to someone that's coming along and looking at all the procedures and looking for a particular procedure. They go, oh, change customer name, iCustomer number. Okay, I got that. That's the customer number I want to change, probably. And iCustomer name. Am I supposed to also give it the name of the customer I'm looking to change, just so that way it can verify that I've actually selected the? So as you can see, there's definitely some ambiguity here. I would have put I_new update or updated customer name, something to help indicate that a little better. Here's our handy dandy begin. In this case, our SQL statement is actually update customer, which is the table, set customer name equal, and here's our iCustomerName. So we're using the input and we're shoving it into the customer name, so that's why it's equal, where customer number equals iCustomer number, our other input. End, semicolon, and slash. Pretty straightforward. And if we ran this, we're going to get the statement process. Depending on the version of Oracle you're using, it might say procedure created or updated, something along those lines. And there you go. Not far behind it, we're going to now talk about deleting data with procedure. Same kind of thing. Create or replace procedure, delete order. And we're putting order number in orders. It's the same type. Now, here is one really good reason to have stored procedures. First, let me say this. In my world, we don't delete data. Data being deleted can never come back. And that means we can never tell you what it was. And let me also tell you that one day will cause you problems. You're going to come across some data that got deleted, and you really are going to wish you knew what that data was. So in my world, most data never gets deleted. We use flags to indicate that a data has been archived or soft deleted, so that way the system won't make use of it anymore, but it never really gets deleted. With that said, let's talk about deleting data. Oftentimes when you go to delete data, because of things we've talked about in the past, such as integrity checks, foreign keys, you can't just delete the data, the piece of data you want to delete. Usually something's going to be connected to it. If you try to delete that data straight out, it's going to give you an error saying, based on, constraints or foreign keys, you can't delete that data. So in our stored procedure here, you're seeing us do a begin. We're going to delete from the order line first this information, which is the order number based on this order number that we gave it. And then it's doing delete from orders where order number equals order. So here's the great thing. So we're creating a procedure that says delete from order. And yeah, in the procedure, we're actually deleting the data first that needs to be deleted so we can then delete the order number. This is kind of what's known as black boxing. We're creating a procedure that's going to do all of it for us behind the scenes. And the customer's not, or whoever's using this procedure doesn't really care how it gets done as long as it gets done. So in this case, that delete order, the first part of it has to delete the order number, the order lines from the order number table. Let me try that again. We got to delete the lines from the order line table that match this order number. Because if we don't, when we do this delete from orders, it's just going to come back with an error saying, hey, you can't delete an order that has order line in the order line table. Otherwise, these lines would become orphaned and would cause corrupt data in your database. So delete those first and then delete those. And that's what our stored procedure does. Same typical thing in semicolon slash. All right. Now, this is going to be the last slide we talk about in this video. It's also going to be the first slide we're going to talk in the next video. And that is because selecting multiple rows with a procedure. PL SQL can only process one record at a time. That's something for you to understand, but there is a way around it. And in the next video, we're going to talk about using cursors. And a cursor is exactly how you handle multiple rows of data and still allow PL SQL to only actually process one record at a time. So come on back in the next video, and we're going to talk about using a cursor.